All right, so this is our first lesson in Unit 6. Since I'm out of town, we're going to do things in a little bit of a weird order. We are going to start with Lesson 4 in Unit 6. This lesson is about dilations. Hopefully you've seen this before. This is something that you should have learned about in junior high, but if not, this lesson will fill in what you may have missed. So we're going to start with a few vocabulary words. Our first word is dilation. This is a transformation that produces an image that is the same shape as the original figure, but the image is a different size. The dilation uses a center of dilation, which we'll define here in a second, and a scale factor to create a proportional figure. So essentially what a dilation does is it takes an image and is going to make it bigger or smaller. So the center of dilation, this is a fixed point in the plane about which all points are either expanded, which means our image is getting bigger, or contracted, which means our image is getting smaller. And then the scale factor, this is the ratio of the new image to the original image. So when we create this image, it's going to be the new image, not this image. When we create the scale factor, it's going to be the new image divided by the original image. So for example, let's say that our original image was a triangle where this side length is 2, and our new image would then be a similar triangle where this side length is 4. Then to find the scale factor, we would take the 4 from the new image divided by the 2 of the original image, and we would find that 2 is the scale factor. So it's the factor by which the image grows. Okay, so let's look kind of at an example here. So triangle A prime, B prime, C prime, those primes are what we use to denote the dilated image. So that would be this one, A prime, B prime, C prime, is a dilation of triangle ABC, which is going to represent our original triangle here, sometimes known as the pre-image, with a scale factor of 3. So the origin point O is the center of dilation. So that's this point down here. This is our center of dilation. And then it gives us the coordinates of our original points. So these are the original ones. And it also gives us the coordinates. I've got that coloring backwards. This is the original. And then this is the dilation. Okay, and then it says the ratio of the lengths from the center of dilation to each coordinate is equal to the scale factor. So if we were to find the length from the origin to A prime and compared that to the length of O from the origin to A, that the difference between those, or the ratio there, is going to be a 3, which means that this comes out to be our scale factor. Something important to note here is that although the side lengths of our image may change, the angles of the pre-image and the new image are congruent, which means they're the same. And the symbol we use for that is just like that. It's an equal with a squiggly on top. But yeah, it just means that the angle sizes are going to remain the same even after the dilation takes place. All right, so let's look at some examples of how this works. Okay, so example number 1. We're going to dilate the triangle with vertices A, which is at 0, 0, B is at 4, 0, C is at 4, 3, by a scale factor of 2 and a center of 0, 0. Okay, so that is important to note there, that our center is at 0, 0. So the next couple examples we're going to do, our center is going to be at the origin. So, okay, let's kind of summarize what we have here. So I hope that this isn't too small, but we've got A is at 0, 0, B is at 4, 0, and C is at 4, 3. So let's go ahead and graph those points. I'm going to draw the X and the Y axis right here. So those represent our X and Y axis. And then let's put those points. So our A coordinate is right here at the origin, which is 0, 0. So this is A. I'm going to make that a little bit bigger because I think it might be hard to see. This is A. B is at 4, 0. 1, 2, 4, 0. This is B. And then C is going to be at 4, 1, 2, 3. So up here. All right, so there is our original image. Now the problem tells us that our scale factor is 2 and our center again is located at the origin. So the way that we do these dilations when the center is at the origin, that's important to note, this is when the center is at the origin, is we just take each of the coordinates, so the X and the Y part of the coordinate, and we multiply it by the scale factor. So to get our dilated image, what we're going to do is we're just going to go ahead and multiply everything by our scale factor, which is 2. So that means that A prime then will be located at 0, 0, since 0 multiplied by anything is still 0. B prime will be at 8, 0. And C prime will be at 8, 6. So let's put those on our graph. A prime is going to be at the same place as A. B prime is at 8, 0. So we got 1, 2, 3, 4, 5, 6, 7, 8, 0. And then C is at 8, 6. 1, 2, 3, 4, 5, 6. So this down here is B prime. This up here is C prime. And if we draw and connect those points, then we will see our dilated image. And hopefully you can see there that that original purple triangle got scaled up by 3, so the red one's 3 times bigger. Okay, so let's just make a note here at the bottom of our page that when the center of dilation is located at the origin, which is 0, 0, multiply all coordinates by the scale factor. Okay, so let's go ahead and look at another example. This is example 2. So it says we're going to dilate the triangle where the vertices are at those 3 locations by a scale factor of 3 and a center at 0, 0. Okay, so our original points, we've got A at 1, 1, B at 4, 1, and C at 4, 4. So if we just go ahead and graph those, I'm gonna put my origin at the same place. And then I'll graph those points. So A is at 1, 1. B is at 4, 1. 1, 2, 3, 4. And C is at 4, 4. 1, 2, 3, 4. So that would be our original image. Okay, and then to figure out the dilation, we need to know the scale factor and the center. So we've got, maybe I'll do this in a different color. Got a scale factor of 3, and the center is again at the origin. So to find those dilated points, we need to multiply everything by 3. So A prime will be at 3, 3. B prime will be at 4 times 3 is 12. 1 times 3 is 3. And C prime will be at 12, 12. Okay, so if we put those on our graph, A is going to be at 3, 3. So 1, 2, 3. 1, 2, 3. I think I got that wrong. 1, 2, 3. 1, 2, 3. Right here is A prime. 12, 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where B prime is located, and then 12 goes to 3, 4, 5, 6, 7, 10, 11, 12. This is C prime. So again, if we go ahead and connect those points, we will see that our dilation has produced an image that is 3 times larger than the original. Okay, so then we've got one more example where the center is at the origin. And I'm going to ask the sub to go ahead and pause the video here and let students work on this example for a couple of minutes to let them assess if this is really sinking in. And then we'll come back to the video and we'll go over this example together. Okay, so let's look at this. Let's record where our points are at. So on our original image, we've got A located at -4, 4. B is at 6, 6. C is at 6, -2. And D is at -4, -4. So you may have found this out, but I shifted my origin since I need to plot stuff negative. So I'm going to have a point at negative 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's point A. 6, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's B. C is at 6, negative 2. And D is at negative 4, negative 4. Okay, so that image that we have to start with is, this is a parallelogram. Hopefully you remember that. And then to find our dilated image, we need to know the scale factor, which is 1/2, and the location of our center, which is at the origin. So to find our dilated points, I'm going to multiply everything by 2. So A prime will be at negative 8, 8. B prime will be at 12, 12. Oh, sorry, I'm multiplying by 2. Excuse me, we are scaling this down rather than up. So we are dividing by 2. So we're going to have negative 2, 2. B prime will be at 3, 3. C prime will be at 3, negative 1. And D prime will be at negative 2, negative 2. And if we plot those on our graph, we have A is at negative 2, negative 2, 2. A prime. B prime is at 3, 3. C prime is at 3, negative 1. And D prime is at negative 2, negative 2. So when you do this, you'll know you'll do it right because the image will look very similar. It'll just look like it's bigger or smaller than the image. And since our scale factor here was less than 1, we ended up with a dilated image that was smaller than the original. So hopefully that's what you got, but if not, hopefully that example helped figure out what maybe is still confusing. All right, example number 4. So this is where things start to change a little bit because we're going to be dealing with dilations where the center is not at the origin. So let's see how this works. Let's go ahead and start by recording where our original image is. So A is at negative 1, 1. B is at negative 4, 1. C is at negative 4, 4. And D is at negative 1, 4. Again, I'm going to put my axes more so in the middle for this one. Sorry, my thing is doing wild things here. Okay, sorry, that was weird. So let's put those on our graph. Negative 1, 1 is A. Negative 4, 1, negative 1. Is here. This is point B. Negative 4, 4, 1, 2, 3, 4. This is C, and negative 1, 4. This is D, so we're starting with a square. Okay, and then let's record the information about our dilation. So our scale factor for this one is 2, but our center now is located at -4, 4. So on our graph, that means point C right here is our new center. Okay, so when our center is not at the origin, instead of just multiplying each of the coordinates by the scale factor, we need to figure out how far from the center the point is located, and then we'll apply the scale factor. So for example here, point A, our original point A, to get from the center to A, for A you had to go down 3 and then right 3 to get there. So that means then that point A prime is going to go down 6. We're going to multiply that change by the scale factor. So it would go down 6 and over 6. So on our graph, we're going to go down 1, 2, 3, 4, 5, 6. So right here, and then over 1, 2, 3, 4, 5, 6. So A prime then is going to be located over here at 2, -2. So then we'll go ahead and do the same thing for the other points. So point B, to get there from our center, we originally went down 3. So when we apply the scale factor, we're going to go down 6. So down 1, 2, 3, 4, 5, 6. Our B point is now located at -4, -2. C is nice because C, there was no change. So C prime, there's going to be no change, which means C prime is still going to be at -4, 4. So it's going to still be here, C prime. And then to get to D from C, we have to go to the right 3. So D prime, multiplying that by 2, we would go to the right 6. So that's going to be 1, 2, 3, 4, 5, 6. D prime then is located here. And again, if we just go ahead and connect those 4 vertices, we will see that our image is now twice as big as it originally was. So maybe if we want to make a note on the bottom of this page, sorry about that. I don't know what's happening. Sorry about that. We are back. So when, maybe not. Okay, let's try this again. When the center of dilation is not at the origin, multiply the distance from the center by the scale factor. So again, now we're multiplying the distances rather than the points themselves. So let's do one more example of this. So this time we have a triangle. Our points, A is at -1, 1, B is at -4, 4, and C is at -5, 1. For this one, we're gonna want our axes actually on the other side of the grid. So point A is at -1, 1. Point B is at -4, 2, 3, 4, 4, 1, 2, 4. And then point C is at -5, 1. We're going to have a triangle that looks like something like that. This is point A, this is point B, and this is point C. Okay, now let us record the scale factor, which for this one is 2, and the center, which is located at -1, 1. Which is going to be where A is at. So this right here is our center. Okay, so since our center is not at the origin, we know we're going to need to figure out the distances rather than the points themselves. So point A, how it moved from the center is that it didn't. So fortunately for us, A prime is going to be A prime. Be consistent with colors. A prime is located at -1, 1. So this is going to be A prime as well. B, to get to B from A, we had to go up 1, 2, 3. That would get us right here. Then we had to go over to the left 3. So to find B prime, then we're going to multiply that by our scale factor, which is 2. So we're going to have to go up 6 and to the left 6. So 1, 2, 3, 4, 5, 6. So up there and then over to the left. 1, 2, 3, 4, 5, 6. So there's not actually a point here. Right here is where B prime is located. And then C, to get there from our center, we go over 1, 2, 3, 4. We go left 4. So to find C prime, then we need to go left 8, which will be 4, 5, 6, 7, 8. So it'll be located right here. You can then go ahead and connect those points. And we see that our new image is 2 times larger than our original. This note at the bottom just says on your homework, you're going to want to make sure you do this on graph paper. You're also welcome to play around with dilations on things like GeoGebra and Geometer's Sketchpad. Maybe we'll do that someday in the future, but you're welcome to look at that if you're interested. Okay, now I just want to go over the homework with you just so that you understand what it is. If the students don't already have the homework, if you could please pause the video to hand out the homework assignment so that they can look through the problems as I look through them. Okay, so looking at our homework, we're going to do 1, 2, and 3 together. So question number 1 says, in math, the word dilate means to expand or contract. Which were the 2 words we used in our definition? A figure. If a scale factor is less than 1, then your figure gets, well, if it's less than 1, we're going to divide those things. So it's going to get smaller. And if it's greater than 1, then we're multiplying it by something that makes it bigger. Good. Okay. So for question number 4, it gives you an image. It wants you here to record the points where J, K, and L are located, and then to use the scale factor to find where J prime, K prime, and L prime are located, and then draw them on the graph. Same applies for number 5. For number 9, similar, you're going to be dealing with dilations. It gives you the points for the original image, wants you to find the dilated image, and then graph it. Question number 14, this is a little bit different just because it's asking you to draw the translation, which we've been dealing with dilations, not with translations. But again, hopefully you've heard of this before. If not, a translation is just a shift. It's not going to change the size of the image. It's just going to shift it left or right or up or down. So for this one, we have triangle XYZ, and that got translated 2 units to the right and 3 units up. So what you're going to need to do is shift each of your points, those shifts, and record the location of your new point. Okay, so that's a translation question. Questions 16, 17, and 18 all have a center that's not at the origin. So you're going to need to apply what we learned at the end of the lesson. And then question 9, 10, 11, and 12 are just true or false questions. So you'll just need to put a T or an F for each of those questions. All right, I hope that this lesson made sense. If you have any questions, feel free to ask your neighbors, or I'll be happy to answer any questions when I get back.